Yeah, hi everyone. Welcome to Pandas 2. So in this class we'll be discussing all of this. This might seem large, but I just to not miss anything, I just wrote down all the key topics. So we'll be continuing on the CRUD operations of rows. Then which is basically we'll be creating we'll be seeing how to add new rows. Then how to delete rows. Then we'll be looking at duplicate handling. Right, and then we'll look at some slicing. Although we did see this in the first class, but I'll be discussing some more some more aspects of slicing, and then aggregate functions. Like you have some count. This is all data summarization things, and then we'll be looking at sorting. Like how we can sort the list in ascending and descending order, how to set multiple, how to use multiple columns to decide how to sort. And then we'll be looking at concat, which is basically nothing but if you have seen NumPy classes, you'll see that it's basically vertical stacking and horizontal stacking. This is like the dumb version of merging just two things together. And then we'll look at merge, which is basically the intelligent way to merge two tables. Well, concat is just like a you can say almost like a one-to-one merge of rows between two tables. Like you have two tables, you just stack them one after the other without any conditions. So like we discussed the other day, if you have so suppose this has user ID 1 and this has a name associated to this user ID, but the second table has so the first table is a users table, and then the second table is a profession table, right? So this has all the professions of this users. So if I have names and user IDs of this in this table, and I have the same user IDs, but they are messed up and their kind of professions are different. So if we do a blind stack, we'll be stacking the user ID one's name with the profession of user ID 3. So this is not very useful. So that's where merging comes. So you merge intelligently. So you say that if the user ID is 1 in both the tables, then merge these rows. So you'll have the name of the user ID 1 and exactly the correct profession of the user ID 1, and similarly user ID 2, user ID 3, and that is that's how you do merging. And you have like inner outer merge. We'll see that at the end of this session. And I'll also be talking about these four things which I think I missed in the first class. Is basically there is another way to create data frames from scratch. You can give you can use dictionaries in row level. We'll see that at the end. And then multi-column access, like how we can access multiple columns at once. And then there's a special method called value counts. If I have like multiple, say invoice 1, invoice like let's say I have multiple rows related to like order details, and I have invoices. And if I suppose have invoice and every person can order multiple items, right? So there'll be multiple invoices in that. So there'll be you can say there'll be multiple products with the same invoice. So let's say there's prod 1, prod 2, prod 3, but there are like the invoice is the same because they are built in the same invoice. So we can use value counts to get this invoice ID count. So like it will get the unique, it will basically tell us how many, how do I put it? It will tell us the count of unique items present in that column. So let's say there is invoice ID 1, 2 and 3 in the entire, like say 50,000 records. So you will see if we do a value counts, invoice 1 has something like 5,000, invoice 2 has 30,000, and invoice 3 has the rest of them. So again, the demo will make it more clear. So that's what we'll be discussing today. Okay, so let us begin. I'll be using Colab now instead of Jupyter Notebook, because there are some strange things happening in Jupyter Notebook for some reason yesterday and even before as well. I thought that was just a one-off thing, but turns out there are some weird bugs. So I'll be using Colab from now on. So let's continue with the CRUD on rows. So the first thing is, how do we add a new row? Right. So let's create a normal data frame. I'll be using this dictionary wise row creation. So let's say I have names is, okay, before that let's do the usual standard stuff, which is basically pip install pandas, pip install numpy, right, already satisfied because I already have that. Just to check the versions, we'll do a PD. Oh, by the way, we'll do the import. Before that, yeah, we'll do the import. Import pandas as PD. Import numpy as np. Let's do the check PD dot. So these are the versions. Okay, so 2.02. I guess I had, I don't know, maybe I had slightly older version yesterday. I don't know. Anyway. So let me create a data frame. We'll call it names equal to pd dot data frame. I'll create a curly brackets, and now I will create rows. So I will do something like, okay, instead of this I'll say it's R1 since I'm doing row wise. Name, I'll say here, then age is 30, then PROFESSION, profession is web dev. Now one drawback of this is we'll have to create the column names in every row, so it's not the best of ways, but anyway, I can just copy, so that's fine. Let's say it's like 33 is in is a React. What else? Let's say the win age is 24. I'll say crypto theft. So we have the 3 records, and then if we want to concat. So before concating, I guess let's just create a table first. But anyway, we can do a concat since we are here. Df equal to pd dot concat. Okay, let's check the documentation first. Value error if using scalar values. Using all scalar values, you must pass an index. Wait, this is not, okay, one second. Okay. Okay, let's do one thing. We'll create this and I'll call it R new. I'll call this R1, R2, and let me create a data instead of a data frame. Create a series and then pd dot data frame merge R1, R2 using all scalar values. Interesting. Oh, this is not a series. 1 second. Right, so I have the names and columns. Interesting. Okay, so there we have the table. This should not happen, but anyway, so we have our table with these 2 rows. Now I want to add the new row to this. If I want to append another row to this data frame, so what I do is I will do I'll use the concat method. I'll say pd dot concat. And then, okay, let's look at the documentation first. Okay, this is slightly messy. Let's look at this one here. So it takes in lists of data frames and it takes access. And it also has a join function. This is similar to merge, but we won't be looking at this one in concat. We'll see that in merge. So these are the 2 things that we need right now, which is basically we'll pass in a list of data frames. So we have our original data frame, which is this one, and we want to add this new record to this data frame, right? So this df comma, I'll say R new, and we can specify access, but the default is 0. So that's exactly what we want, right? We want it right below, so we don't really have to specify. If we see the result, you see the this record got added at the end. Now you see the index is kind of messed up, right? So what do we do for this? We have to give this we have to pass this argument, ignore index true. If we see the documentation, default is false, and if true, do not use the index values along the concatenation axis. Right? The resulting axis will be labeled 0 to n minus 1, and that's exactly what we want. Let me just copy this, ignore index. True. And you see the indexing got set properly. We have 0, 1 and 2. So that is how you add a new row at the end. What if I want to add somewhere in the middle? I want to maybe not add in the middle, but kind of replace in the middle. You cannot exactly add in the middle, if I'm not wrong, because you can only replace. Let's see, is there a way to add in the middle? No, you cannot. At least as far as I know, I don't think we can add in the middle, because no. Let's see with lock and ilock. Ilock will replace. So let's look at ilock first, because we can set the index for ilock, but that ilock will replace that that row with the new row. It will not add a new row. Lock will add a new row, but it will only add at the end. But I think we can add in the middle as well. Let's see. So we can do something like pd.ilock. Okay, not pd.ilock, df.ilock. So okay, so we let's replace the first or rather the second row with a different data. So let's do something like let's take this one and let me rename this to Baki, and then his age is 22 and his profession is a fighter. So we'll set the, so we know ilock, right? Ilock is implicit indexing, and which means Python based. So if I want to set the first at the first index, we'll exactly pass the first index, since this is 0 to n, and I'll pass. So I want to replace the first index with this one. So, but the problem is this is a dictionary, right? So we'll get the values. I want the values of this dictionary. So r dot values will give me the values. I can actually set it as it is, but we can wrap it onto a list. And then if I set it, you see the first index got replaced with fighter. So now, by the way, why did the second index? Why is the second index not visible? Because we didn't do an in place. We should do an in place operation. If we see concat, ignore levels. Interesting. Wait. So we have 3 of them. Now if I add df, strange, Baki. Okay, there it is. So surprisingly, this does not have an in place, or am I not seeing it? Verify levels. Okay, it doesn't have an in place, but if I reassign the concatenated data frame to the original data frame and then perform the operation, you will see that the second index got replaced with the row that we wanted. Right, the second row got replaced, and that's how iloc works. You can obviously replace the last index as well. So you can do something like, if the list is too long, suppose, and you don't know the index, and if you want to just replace the last index, so you can do something like df dot index. We know df dot index gives us the list of indices, right? So we can then get the last index value. If you do a negative indexing, we'll get the last index value, and that if we set it to something like maybe UGZ maybe 50, and let's call him a pro fighter. If we set it now, you will see the last value got replaced with this one, with the row that we wanted. If I try to add a new column, right, you will see what happens. It will throw an error. iloc cannot enlarge its target object. No, it will not. If we want to enlarge if we want to add a new row now, we'll have to use lock. Let's use the lock method. Let's call it I don't know, like Maki, and then 19. Let's call her Singer, and then if I use a lock, right? So what is lock? So lock is label based, right? So it's not exactly it's not index based. It's the label. It considers these indices as labels. They are not. It does not think of them as numbers. So if I get so if I want to add a new index, then I can do if I want to add a new row, I can get the last index, and if I do a +1, that will create a new row, and then if I execute this, then you will see that it enlarged the data frame. So if I run it again, you will see there is a 4th column, there is a 5th column, and there is a 6th column. So something like this. Now let's look at the thing that we discussed. Can we add a new row in between? So let's say I want to add I'll add a new row right after Anand. Okay. Let's see. I didn't try this before. Not getting any names. Say Apurva, age 15. Dancer. So if I want to add at index 1, let's see what happens. Index, I'll set the index to 1, which is basically, let's not call it index, I'll set the label to 1, index label as 1, and then I'll add this value here. Let's see what happens. Okay, so did it override the first value? Did it? I actually don't remember. What was the first one? Was it Baki? it was Baki. So turns out it will also override. I don't think you can actually insert the value in between. Let's see. Let's just use some animal names. I don't know. 29. Camel. Traveler. If I set the value to 1 again, yep, it actually replaces. You cannot insert a row in between. So I guess the only way, I mean, if you do want to insert something in between, the only way I can think of is you should probably split the data frame into like the place that you want to insert and then like the row that you want to insert, split it, then append the new row there, and then concat all three of them to get your final output. It's a bit tedious, but yeah, that's the that's the only way I can think of. So yeah, that's about adding new row. Let's look at deleting rows. So deleting is basically we use that df.drop. Drop. Okay, df. I guess I already have a data frame preloaded here, so that's why this is showing. So ideally, okay, let's just take this data frame just to avoid confusion. So we have our df. Now we'll do a df.drop question mark just to see the. So you see, it takes labels. It does not take indices. It's label based. So this takes explicit indices. So let's do df.drop. Now if I want to drop, so we have ton of duplicates here, right? So if I do a drop, I want to drop the 6th label. Okay, before that, let's look at all the other things. It takes access. Default is 0, right? I can do an in place as well. That's I guess these are the 3 arguments we'll look at right now. So if I do a df.drop 6, so you see the 6th one is gone. Now if I do a df.drop, I want to drop the first index. First is gone, but if you see the indexing is messed up. Right now it's not in exact order. It's 0, 2, 3, 4, 5, 6. So if I want to reset the index, what do I do? Right, so if I want to reset the index, what I have to do is df dot reset index. We looked at it in the first class, right? So reset index. Okay, what are the arguments of reset? We have to pass the drop because do not try to insert index into data frame column. So let me just show you anyway. We already saw this, but if we don't, so we can just say reset index. But if we don't drop it, then what will happen is it will create. You see these indices. It will. Okay, we didn't do an in place. Let's do an in place. Okay, not found. Yeah, 1 second. So we have our original df, and if we do a reset index, you see it took these indices as a separate column, because like we discussed in the first class, we have something called df dot set index, right? And I can set any of these columns as indices. So that's actually real data. So we don't want to lose the data, right? So in order to avoid losing the data, it will by default store that store the index column as a index list as a separate column. Now, since these are unnecessary for us, we'll just do a drop. It is drop, right? Let me check. Drop here. Drop is true. Now, if I do a drop true, you'll see the indices got reset, and we don't have the unnecessary index column. And that is that's how you delete some rows if you want. And then let's see, I think we can we delete multiple of them? Wait, let's see, can we delete multiple rows at once? I don't think so. So if I want to say, so let's see, what is our original? So this is our thing. Now if I want to drop 2 and 4th row, and if I do an in place, oh, so you can do multiple as well. Okay, so this is deleting multiple rows at once. Again, the theory is the same. And as you saw, the if we don't specify the drop true, our indices are okay. That's in reset index. So our indices got messed up. So we can do this again. Drop reset index, drop true, and we have our proper table. So that's all there is to deleting the row. Now let us look at handling duplicate rows. So how do we find duplicates? So I mean, this is a perfect table for us. How do we find duplicates? So the procedure is very similar. Finding and extracting the duplicates, very similar to NumPy. We'll use Boolean masking. So if we do a df, there is a method called duplicated. Let's look at the documentation. So it takes in a sequence, and there is a keep as well. There is what is it? It takes subset is column label or sequence of labels, and keep. So there is a first, last, and false. We'll look at this, but before that, let's just and what does it return? Returns a Boolean series for each duplicated rows. So if I do a df dot duplicated, you see it returned a series. Let's look at the type. So type is a series. So it returns a series of Boolean values, and just like NumPy, whatever, if we pass this Boolean value Boolean list to the data frame, it will retain all the true values and it will discard all the false values. So all we have to do is df brackets, square brackets, and if I do a df duplicated, you see it will give us the duplicate values. So the true values are these two, right? These two are the exact duplicates, or rather these three, but these two are the extra ones. And so these two are the unnecessary rows in this table. Now we found the duplicates, so how do we get rid of them? Right? How do we delete them? So we can do something like df dot drop, if I'm not wrong, duplicates. But I think yeah, this is the method, drop duplicates. If you see the arguments, once again the same type of arguments, it takes a sequence of labels and column labels and column label or sequence of labels, and then there is the keep as well, which is keep first, keep last. So the keep makes more sense in when we see the drop duplicates, but again, let me show you here as well. If I said drop duplicates, if I say keep, okay, let me do it here. Drop duplicate, no, not drop duplicate, dot duplicated. If I say keep, what do we have? Keep, so by default it's first. So that's why you saw the first value got retained, but it said 2 and 3 are duplicates. Now if I say keep is last, so you see the it kept the last value. So false means it's not considering 6th row as duplicate, but it's considering 3 and 5 as duplicates. And what's the other one? Okay, first, last, and false. So if I set it to false, then mark all duplicates as true. So which means it will consider all these as true. See, true, true, true. So it'll get rid of all the duplicates. Again, this will make sense when we are actually deleting the duplicate. So let's look at our data frame. So this is our data frame. We have 3 duplicates exactly, or rather 3 rows that are exactly the same. So let's drop the duplicates. I want to drop duplicates. I'll say keep. By default, keep is first, right? So let me see. So you see, it kept 0 and 3, which is the first 2, and it dropped the other 2. Does it have in place? Let me check. Yeah, there is in place. So yeah, that's fine. We don't have to make permanent changes here. So we'll now I'll use the keep as. So we saw keep is first by default. So anyway, this will be the same. If I do keep last, you see it kept 0 and 6. So of these 3 same rows, it kept the last row, but it removed the 3rd and 5th rows. Now if I set to false, then you will see it will get rid of all 3. All things that are similar will be removed. So it got rid of all 3. So that's how you handle duplicates at a complete row level. Like this works when every single column value is the same for all these rows. Now if I want to say, suppose if I want to delete duplicates based on a column. So suppose I have this age where all these 3 columns have age as 19, but maybe the names are different. So I guess we'll have to construct a new data frame. I'll copy the same thing. I'll just call it R1, R2, R3. I will taken the same things. And I guess let's create more. Let me create more of them. R4, R5. So let's just to make things easier, I will just use the same thing. I'll just change the name slightly. It's Bananand, C, make it D, I'll make it E, and the ages are the same. Okay, and yeah, I mean, I guess these can be like blockchain. I don't know. Finance guy probably. Okay, so we have age. All these three candidates have age 24. All right, it's called Khan and then E and whatever, some random names. So 1, 2, R4, R5. Let's check the data frame once, how it looks. So we have our data frame. Now, okay, so what I want to do is I want to drop all rows whose age is 24. Okay, or I only want one person aged whose age is 24. I don't want like 3 people aged 24. So if so how we can do this is df dot drop duplicates, and if you look at the documentation, you have the subset, right? So we can pass the column name age. Now I'm passing the age, and I'm saying, so keep is anyway first by default, right? So if I do this, so you see it got rid of the other 2 people whose age is 24, even though the names are different. So this one starts with C, this one starts with D, this one starts with E, right? And the professions are also different, but since the age is the same, it kept the first record whose age is 24 and got rid of the other 2. Again, this is the keep functionality. It's the same. So now if I want to keep the last guy, you see it kept 1, 2 and 4. It kept 0, 1 and 4 and got rid of 2 and 3. Now if I pass this as false, obviously it will get rid of all the people whose age is 24, right? So that's how you do column level duplication finding and removing. And this by the way, this works on this method as well, duplicated method as well. The functionality is the same, but I showed you this first because the output is much clearer. So I can say I can pass age, and then I can I'll set keep as false. Let's create the same previous example. So you see here it gave booleans false, false, true, true and true. So literally it considered the bottom 3 as duplicates and stuff that must be removed. And if I want to find those 3 duplicated values, I'll just pass this thing as filter. So I'll do something like df and then I pass my boolean mask. So you see it gave me the 3 people whose age is 24, or rather 3 ages that have the, or rather 3 ages that are exactly the same, even though the names are different. So that is basically how we handle duplicates. Now let's look at slicing. Um, if I'm not wrong, I think we did see row column slicing, but since that came somewhere in between in the previous class, I don't think I discussed explicitly like how it's done. So let's do slicing on this data frame itself. So I do. So again, we know the syntax, right? The syntax is rows and columns. And rows and columns have the same start, stop, step. So for rows we have start, stop, step, and for columns we have, rows and columns. And columns we have start, stop, step. So if I want to get the first, let's look at our data frame. So if I want to get, say, the first two rows, I'll do something like 0, first two rows, and we'll use ilock. Again, we can use lock and ilock. I'll show with ilock first. So we'll do 0 to 2. Since stop, or rather the end is excluded, right? So we'll do 0 to 2 to get the first two rows, and I want all the columns. So you see we got 0 and 1, which is the first two rows, and all the columns. So now if I want just the first and second column, then again the same will get name and age, again 0 to 2. Obviously, since this is ilock, we can do negative indexing as well. So suppose if I do start, stop, we have to give step size -1. The end would be, let's say I want the bottom so I'll start from -1, which is basically the fourth index, right? And then I'll end at, maybe I want to stop at the second one. So -1, -2, -3. So we have to give -4 because this is -4 is excluded, right? So till -3, which is so till the second index we want, and then let's say all the columns. So you see we got fourth one, third one, and then we got the second one, right? And then all the columns, and the same applies here as well, to columns as well. So if I want, let's say I want profession and age. So step size -1, I'll start from -1, which is basically profession, and I'll stop at age. So -1, -2, so until -3. So we got profession, and we got age, and we got 4, 3 and 2. So that is slicing, start, stop, step, and yeah. So we can obviously set step size. We can set different step sizes, right? So suppose I can do -2 as step size instead of -1. And I'll ignore the end, so it will be till the end. So if you see this, you see we got the fourth one, and then since it's -2, it skipped the third, and it got the second one, and skipped the first, and it gave us the 0th. The same with columns we did, it gave us profession, it skipped age, and it gave us name. Again, if we can look at this in positive indexing as well, so we can do something like start, stop, step is 2. Again, start, stop, step is 2. If we do that, we have 0, 1 is skipped, we have 2, 3 is skipped, we have 4. And same with profession, columns, we have name, age is skipped, and profession. So that is step size. You can increase the step size as much as you want. Let's do a step size 5. Since okay, let's do step size 10. Probably throw error since there is no index 10. Interesting. It actually didn't. It didn't throw any error. It just gave us the Obviously, it gave us the first. It gave us the first one because it starts from 0, right? So if we do a 2, it will throw an error. No, it didn't. Okay. So it will always consider the first one. So it gave us the second row, but obviously there's no. We don't have like 100 rows, right? So there's no step size 10. So there's no 10th row as well. So it looks like this does not throw any error. So let's look at lock. Now lock is label based. So if we do this, it will throw an error because there are no columns with labels 2. There's no column with label 2, right? Cannot do slice indexing 2 of type int. So there's no such thing. So and there's no steps. There's no concept of a step, if I'm not wrong, in lock. Oh, there is. Okay, there is. So we can do the same in lock as well, since these are label based. But if you see, the lock is end inclusive. So if I do okay, so this is step size 2. Let's take 0 to 2. So if I do a 0 to 2, so I will get 0, 1 and 2. So I'll get first 3 columns with this. Can I do slice indexing? Okay. We don't have the 2 label, right? I'll do name to profession. So we got all three columns because it is end inclusive, and I got 0 to 2, right? So because this is end inclusive, I got all 3 rows. Now if I give 1 to 2, it will give me exactly 1 and 2. So that is that's basically slicing. And then we can do some cherry picking as well. So if I want to get exactly these particular rows, so let's say I want the 0th index and I want the 3rd index and I want the columns I think this should be on lock. So if we do a lock and I want exactly the name and profession. So you see, we got the 0th and 3rd rows and we got the name and profession. Let me check this one. I think this will throw an error. Yeah, that will throw an error. Obviously ilock won't support this one, so ilock we can do. I want the 0th and last index 0, 1 and 2. So that's how you do with ilock as well. So this is cherry picking. So we can get exactly the columns and rows, specific columns and rows that we want. So that's all there is to slicing. Okay. Let's look at aggregate functions. This is pretty straightforward. So check our data frame. Okay, so we have a convenient numeric field. So what we can do, there are 5 common aggregate functions which you will which many libraries use, which even if you see if you have used SQL, you will see these same aggregate functions there as well. The functions are basically some, yeah, you have them here anyway, I wrote them here. So you have sum, count, min, max and mean. So let's do the first one. Let's get the column age and we'll do a sum. So we'll total, we are basically operating this on a series. If we look at the type is obviously series, right? So we are doing a sum, we are totaling all the ages. So that's giving us 135. What if we do a count? That's obviously 5. We have 5 records. If we do a min, so minimum age is 24, which is correct, right? Max is 33, and if we do the mean, which is the average age is 27 in this table. So that's I mean, that's all there is to aggregate functions. There's nothing beyond this. These are the most common aggregate functions. Now let's look at sorting. So sorting, let's look at our table once again. This is our table. Sorting again works, the kind of arguments it takes is very similar to the ones we saw in drop duplicates and duplicated methods. So we can sort, either we can sort entirely based on a single column, or we can sort based on multiple columns. Okay. I think I forgot to do multi-column duplicates. So let's do a multi-column duplicate once. Before that, that's what I was thinking. So if we look at duplicates, based on multiple columns. So if I say I have okay, unfortunately we don't have a name that is similar to this one. Okay, let me just recreate this once again. So we'll create a new data frame where the name is same. There is the same name, but this guy has 2 professions, right? Let's check our data frame once. So we have his age same, and we have his name is also same. So if if we pass multiple values, say suppose if I pass multiple columns, name and age and name, the order matters, by the way. No, I guess order doesn't matter here. Wait, let me check. So if I say keep, let's do the default keep first. So if you see this one, 0, 1, 2 and 4. So it got rid of 3. It got rid of 3 because default age is first, right? So if you see, what happened is, it is checking both age and name as the criteria. Instead of just age, it's checking both age and name as criteria. So if age and name are exactly the same, then it's considering these 2 columns as those 3 columns as duplicates, and it's dropping the what is it dropping? It's dropping the 3rd column, because now there are only 2 duplicates. Sorry, not 3, 2 duplicates. Age wise there are 3 duplicates, but name and age wise there are only two columns that are considered duplicate, right? So these 2. So what it did was keep was first by default. So it got rid of the second one, which is basically index 3. Now if I keep the keep as last, it will get rid of the second one, right? Because it considered the third one must be kept, and so it deleted the second one. So as usual, if we do keep as false, it will get rid of both of them. So again, this is multi-level duplicate finding. So we are finding duplicates based on 2 columns now. So if those both columns have the same values, it will consider those 2 as duplicates even though the profession is different. I hope that was clear. I don't think I can I can make this even clearer, but I think I hope that was clear. So now let's look at the sorting. So let's look at sorting. So there is a method called df dot sort values. Let's look at the documentation for this. So we have sort values. Basically, again, it has the same sort by, which is the index label, which is our column labels, and we can set the axis as well. And we have obviously in place to modify the original array. And these are the and then I guess we will be looking at ignore index as well, but let's see. Let's look at sort values. Let's see what this does. Default sorting, data frame sort, missing one required positional argument. So this, we have to pass an argument which is basically the column. Let's say I sort based on age. So you see all the the default, if you see the default, ascending is true by default. So it will the default sorting is small to big. So age 24, 30, 33, and that's the ascending sort. So if I do ascending false, it will do a descending sort. So the big ones are at the top and the small ones are at the bottom. This is a single level sorting. Now if we do a multi-level sort, we can do something like, I can pass multiple columns as the arguments in this one, and I can pass age, and since we have conveniently this name, we'll do a name, the name column. And if we do a multi-level sort, you see these two came first and then the rest of them. Okay, I guess this is not the best example. Okay, let me recreate this data frame once again. See, so we have our names, and all names are unique, by the way, but all ages are, we have 3 duplicate ages, and professions are all different. So okay, I guess I could have done it on profession, but yeah, that's fine. We'll do it on age. Age is simpler to look at. So if you see here, what is our original one? We have we are doing an ascending sort based on age, and if age is matching, then it will look at name. and these are all sorted lexicographically, which means it will look at the characters, or rather the what do you call this, alphabetical order. Let me check once. Is it lexicographic or sort values along either axis, string or list, name if axis 0, list of names to sort by. Yeah, think of it as alphabetical order. So it will look at the first character and then consider its position. So if you see here, if we did not mention age, it just sorted. You see, D came first, and age was 24. C came next, even though age was 24. But if we specify name, you see C came first now. So it what it's doing is it's checking for age first. So ages are same. Because ages are same, now there has to be a tiebreaker, right? So then it's checking at the name column and seeing if, okay, let's see whose name comes first, and then it is considering, it is sorting these names and then considering the C as the first option. So the name is like a tiebreaker. Now if you give a descending, SEENDI, ascending, false. Oh, right. We have to pass two of them. So ascending, since we have two columns now, we have to pass two of them. So I want age to be sorted. Yeah, I want both of them. Okay. Let me check this one first. Data frame sort values got an unexpected keyword organ. Ascending. So I guess even single also works. Yeah, so if you see here, 3330, you see this one, it considered E is the greater alphabet, right? I'm not sure if you are aware of ASCII values, but in ASCII values, E is the greater alphabet. ASCII table. So if we see, so if you see this table, we have where is this here? So we have character A has value 65, but here if you see our character E, if you see character E is 69 value. So 69 is greater than 65, right? So that's how it is ordering these rows. So E came first, since we are giving a we are going descending order. Even though these two are same, E came first, then D came next, and C came at the end. We can do multi-level sorting here by giving. I want age to be sorted in descending order, but names to be sorted in ascending order. So if we do this one, now you see C came first, even though C value is lower, since we gave name sorting as ascending. If you see, C is 67 and E is 69. So since name sorting is descending, we are getting the names are sorted in descending order, and that's how you do multi-level sorting. This is a bit hard to explain, but I think that was clear. I hope that was clear, and that's all there is to sorting for now. Let's do concat. So concat is basically we are trying to stack two tables, like I said at the intro, like we are doing almost a dumb stacking of two tables. This is same as NumPy's VStack and HStack. If you watch the NumPy series, you are just merging two tables horizontally or vertically. There's no logic or there's no condition, it's just a blind joining. So let's see, let's create two tables. Right, okay, let's I have the df, so yeah, I'll keep the same df and let's call it I'll call it df1, and so we have our df1. Now let me create df2 just to give you an idea of what it is. So yeah, I don't want to deal with so many rows, so I'll just we'll create we'll create some new columns. There is a something I want to show you. Let's call the new column as height. Let's call it height. The height is this guy is 6 feet 4 inches. This guy is let's say 5 feet 9 inches, right? So, and I will stack these two. I'll call this df2 and let's print our data frame. So we have our new data frame. So we have df1 and df2. Now if I want to stack these two, let's see, we have the method called pd.concat. Let's look at what the documentation says. Again, so it takes in two data frames. So we have our two data frames ready. We can specify the axis. Now this is where the stacking comes. So if we specify axis as 1, it will stack horizontally. If we specify axis as 0, it will specify vertically, and the default is 0. So let's give the two data frames df1, df2. So you see here, if you observe this, there is no column called height in the first data frame, and obviously age and profession are not present in the second data frame, right? So what it did was, when we did a vertical stack, it added all the other column as well, and whatever columns it was not able to find any data, it just added the placeholder as nan, not a number, as a placeholder, and then which is basically null in Pandas. That's basically the null value. And if you see here, this is not intelligent stacking, right? So even I have the name Anand already here. So what I would expect is, I would ideally like this name to be the same, and whatever data is there it will fill, and the rest of the columns it will add intelligently. That we'll see in the merge section. But as you can see here, this is just a blind stacking of both the tables, and the good thing is, even though the dimensions are not matching exactly, it still managed to like stack both of them without throwing any errors. So that's one good thing compared to NumPy. Although in NumPy as well, we know, right, there are some broadcasting rules. So it would ideally pad this pad these values with ones or zeros. So yeah, in NumPy as well you can do some level of alignment, but as you can see, this is a nicer way of doing things. Now let's do a horizontal stacking. If I give axis 1, so as you see here, if we set axis to 1, the the columns got added on the right, so horizontally, and then all the other values that it could not find, it just replaced them with null values. So that is basically concat. There's nothing, you won't find anything complicated here. It's just plain stacking. What we can do is, if I'm not wrong, if we set ignore index as true, what does it do? If true, do not use the index values along the concatenation axis. So see, right now our indices are messed up in this scenario, right? If we do the vertical concat, suppose, you see the vertical concat, the indices are messed up. It will retain the original indices of the table. Now if we don't want that, we can set ignore index as true, and it will automatically reset the indices after the stacking, after the concatenation. So that's all there is to concat. Let's look at merge. So merge is basically, merge is similar to SQL merging. I don't know if you have seen SQL. In SQL, you have, if you know these SQL queries, select star from, then you will have table, say suppose table 1, and then we do something like inner join on table 2, sorry, inner join with table 2 on like a particular key, say user ID, table 1 dot user ID equal to table 2 dot user ID or some other column ID. We can join them based on this, right? So this is similar to this SQL statement. So let's see, we have df dot merge. Let's look at the documentation. So you see here, so there is a left index, right index. If I'm not wrong, there should be a left on, right on, but okay, so okay, I guess there is one more, there should be one more should be one more argument called left, but for some reason it's not here. Let's see. So actually this thing, it the syntax would be, we have two data frames, right, like df1 and df2. So we can do something like df1, which is our left, so we call df1 as left. Yeah, let me just write it. Df1 is left table, then df2 is right table. So it's on the right, df1 is on the left. So if we do something like df1 dot merge, the right argument is our df2. Now if we press enter, you see here what it's doing. We did not mention any key value as well, but it automatically understood that the names are the matching, the names are like, the names are similar in both the tables, and it used these names as the keys to merge both the tables intelligently. So if you see the first table, what's our first table, by the way? Where is our first table? So this is our first table. Yeah, let me just print both of them. front df1 df2. So you see here, actually I like this one better, df1 df2. Okay, so you see here the first table has name Anand, right, and age 30, web dev. Second table has name Anand but height is 6 feet 1 inch, so 6 feet 4 inch. So it merged both of them based on the name column as the key. So name is Anand, age is 30, profession is web dev. So what is his profession? Profession is web dev, and it properly merged the height as 6 feet 1 inch. So there is the second one, Anand, and age 33 is React dev and height is 5 feet 9 inches. And since there are no other matching keys in the second table, so there is no Kanand and Danand and Yanand, right? So in the second table, so those three are ignored since this is by default inner join. So if you see here, there is a on. This is the place where we give the condition. So the on is by default. What does it do on? Column or index level names to join on, there must be found in both data frames. If on is none and not merging on indices, then this defaults to the intersection of the columns in both data frames. So it did an intersection on both the like it found the columns that are same in both the tables, and then it did a merge based on those keys. And if you see, there is one more condition that we have to look at, which is basically how, right? This how is the most important one here, and the how is these four, what do you call them? The four types of joins that you can do, four types of merges. So there is left merge, right merge, outer merge, inner merge. Right now what we saw was inner merge, and then there is cross merge. So if you look at inner merge, what it does is use intersection of keys from both frames, similar to a SQL inner join, preserve the order of the left keys. Okay, the last one is not so important, but what you have to infer from this, or what you have to understand from this, is it will only keep the values. After the merge, it will only keep the rows which are matching in both the tables based on this key. Let me just add the how as well. Inner and on name. So we did on name. Now if we do there is inner, if we do an outer join, let's suppose we want to merge all the both the tables, and we want all the records in the first table and all the records in the second table. So see, it literally, you can say this is one, in one sense it just stacked it, but it stacked it intelligently. I guess, you see, I guess it's better to take a different example. Let me do one thing. Let me take a different example. Age is this, so I guess df1 is fine. Let's call this df1. What we'll do with df2 is in df2 let's call this as Dund, and his height is this one. Okay, now we have our df1 and df2. So this is our df2. Let me take the same. Let's check df1. Yeah, we have df1, df2. So So you see, now let's look at the inner join once again. Ooh, there's a significant lag, I don't know why. Okay, let's do df1, df2. Okay, so these two are our tables. Now if we do an inner join, you will see what I'm saying. So you see here, the key is name. Now what did it do? So it checked Anand, that is the key, and it got all the records based on this key. Now the other thing, you see, if we had stacked them vertically, I guess that's the thing I have to show you. Wait. So pd dot concat, if I do a concat on these two horizontally, suppose df1, df2, axis is 1, which is horizontally. Okay, so if you see here, the when you do a concat, it stacked the wrong rows right next to it basically stacked the wrong rows next to each other. So the guy with the name B, his details got added next to the guy with the name D, right? So this is giving us incorrect. This is an incorrect merge. This is not very useful. So, but if you look at this one, this properly merged both of them, and it gave me just the rows that got matched with this particular key. So in df2 there is a name Anand. In in df1 there is a name Anand. Wait, where is it? Yeah, df1 there is a name Anand, and df2 there is a name Anand. So it took that name, and then okay, let me, I guess, interact. Let me show you here. So we have so when we do an inner merge, one sec. Okay. Yeah, so when we do an inner merge, where is it? Suppose we have table 1 with the, yeah, I guess I'll take the same example. So we have name, age, profession. This is table 1. Then we have table 2 with name and height, right? So here we have a guy with name. Let me use the same exact one. We have a guy with name A, and then we have a guy with name B, C, D, and E, right? And then we have all the details of this one, and then we have a guy with name A, and we have a guy with name D, right? We have his respective details. When we do a concat, the concat is like a dumb concat. So where is undo? Where is undo? So it is what this is doing is it's stacking A, B, C, D, E. It's stacking the A value with the A value and stacking the B value with the D values, right? This is incorrect info. Wait, what is happening? Right, so I don't know how much you saw, but basically we have two tables with A, B, C, D, E, right, which are the names starting with A and sorry, we have two names, two tables with A, B, C, D, E, and the second table has names with A and D. So when we do a concat, what's happening is it is concating a value with a value, and that was a lucky coincidence. Now we have a second row with name B, but we have a second row with name D in the second table, and it is concatenating these the B guy's details with the D guy's details. That is not very. It's actually not. It's not at all useful. Now, what inner join does is, or rather inner merge, it will check this A. It will match the record of A in the table 1 with the record of A in table 2 on this key called name. So the name is key. It will check, okay, the table 1 name is A and table 2 name is A, and that match. So it will properly concat, or rather it will properly join these two rows next to each other. So you'll have name, age, profession, and then height. It won't create these duplicate columns again. Right? So this is a intelligent way of merging. And if you see, the next one is the key. And the inner join is basically whatever that are common in both the tables, only those two it will fetch. So in these two tables, A is common and D is common. All other like C, E and B are not common, so it will discard those. So A and D columns are taken, and the values are appropriately populated. There is another merge. Then if we look at outer merge, what is outer merge doing is, it will, again interestingly, you'll see here, let me get rid of this. You have these two tables, right? You see here, this is like the best example. If you see, Anand is, since it's in the first row, it got stacked properly. Now if you see, the guy with the name B, he doesn't have a height, so it properly set it as null. C also doesn't have a height, it properly set it as null. Now D is matching properly. So D, the details are age is 24, there is his profession is blockchain, and his height is 5 feet 9 inches, and that got matched properly. So this is the advantage of merge over stack. It will properly populate the data from both the tables right next to the correct key value that we specified, or rather the correct names that are present in both the tables. So outer join is like full join. So it will outer join is basically whatever merges. So not whatever merges. So if the key is A, it will get all the records where the key is matching, and it will fetch the rest of the records as well. So it will basically get all the records. Just think of it that way. It will first get the records that are not first exactly, but it will get the records that are matching, and it will also retain the other records, and whatever values that are missing, it will just keep it as NaN. Then there is we have what else do we have? Outer left, we have left join. If you look at left join, you see the left join is basically, what is left table here? Our left table is df1, right? So df1, if you see, how many are there? df1 has four records, rather 5 records. So left join keeps all the data that is present, that got matched in both the tables, and everything else that is present in the left table will also be added. So if I have to show you, left join is basically, suppose there are 5 records here and 2 records here, table 1, table 2. So left means So these two records that got matched, keep two matching records and keep all records of the left table. Discard all non-matching records of right table. I guess I'll have to create a I think I'll have to create a new data frame. 1 second. So let's say I have a new row called Zand. Somebody called Zand. He's also 5'9", 5 feet. Let's call him 5'8". Right. Let me run this one. Does not match. Okay. R3. So we have our two tables. Let me run df2 now. So if you see our two tables, there is a guy called Zan. There's a guy with the name Z. Okay, there's a person with the name Z who is not present in the first table in the left table. So if you do a left join now, or rather let me start from inner join. If you do an inner join, again there are only two matching people, right? In two matching keys in both tables. So there's one with Anand and one with there's one with the name A and one with the name C, right? So inner join is basically inner join is basically get me rows where the keys are matching in both the tables. Then if we do an outer join, we'll get all the tables, all the records of both the tables. So you see here, the left table has 5 of them, right table has 3 of them, and of the 3 of them, 2 of them are matching in both the tables, right? So we have totally 6 records. I hope that was clear. Now if we do a left join, you will see here, it will give us the matching records which are A and C. So we have A and C matching, and then it discarded the second record. The person with the name Z got discarded on the right table since we gave a left join. Now if we want the all the records of the right table, but we are not particularly concerned of left table's leftover records, then we can do a right join. Now if you see, A and C got matched in both the tables. So there is a person with name A and there is a person with name C. So both are matching, but there is no person with name Z, and there is no person with name B, D and E. So since we did a right join, which means we want all the records of the right table. So we have all, now we have the person with the name Z in this table as well. But all the left table's leftover records which did not match the key got discarded. That is basically left, right, inner and outer join. Now let's do a cross join. Cross join is Cartesian join or merge. Basically what it does is it matches every record of the left table with every other record of the right table. So I guess it's best to show it. So you have table 1. Okay. What is undo? So you have table 1 with 5 records, 1, 2, 3, 4, 5. You have table 2 with let's say 2 records, let's say 3 records. So what this does is it matches every record with every other record. So you will have this and this and this, this and like this. So the total number of records you will see is I think it is you will see 15 of them in this case. It is 5 cross 3. Now in cross join we don't specify the condition because it will literally match every record with every other record. So if you see now, you will see there are 15 records. So what it did was it matched with it's one sense a blind, not exactly blind, but how do I put it? It's just a, yeah, you just have to think of it this way. It's every record is now set with every other record in the second table. So the first row is next to this one, is next to this one, and is next to the second one. So you see here, there are 3 Anands, there are 3 person with the name B, there are 3 persons with the name C, 3 persons with the name D, because the right table has 3 records. So that is how you do cross join. This is this has its use cases, although I don't exactly remember where this is used, but I got a, like, I saw a use case in SQL once. Yeah, but you just have to remember this for now. So, and that is all there is to merging. Yeah, now let's look at the leftover sections from the previous class. These are basically pretty simple ones. So we already created data frame row-wise, which is basically this way, right? This is the row-wise data frame using dictionaries. The other ways of creating data frames, you can refer the first class. We can use just lists and then stack them together, and then we'll have to add columns here, right? So that is you can check the first class. I think this class is getting too long, but this is the way you create a data frame using dictionary. The other one is multi-column access. We already saw this few few minutes ago. I can just access multiple columns using a list. So since we have this, let's see, what is our data frame? So we have this data frame. I can access age and, if I want, age and name. So I get a output data frame. The output is a yeah, that's the distinction here. That's the important thing. The output is of type data frame. If we check the type of this one, it's of Pandas data frame. But if we just access one column, if I just access age, this is of type series. You see, it's of type series. There is one important thing that you have to remember. If I do a df, if I use the multi-column access syntax for a single column, the result will be of type data frame. This will not be of type series. So if you see type here, it's of type data frame because we are using the multi-column access syntax. So that's how you access multiple columns. And then there is something called value counts. Something. Let's see. This is quite convenient. So we have our data frame. If I do a value counts on this, you see it's giving the count of every unique row. Now this is not very useful, so let's do it on a series. I'll do this on age. so you see here we have ages 24 which are of count 3. So there are 3, so it will give us you can say it will give us the count of duplicates, or yeah, you can think of it that way. It will give us the count of duplicates of every value within a particular column. And if you do it on a table level, it will give us how many duplicate rows are there. So shall we try it on at row level? Let's see. I mean at table level. I will do this thrice. Let's call it R1, R2, R3. So I have my df1. So if I do df1 dot value counts, you see here it gave me that there are 3 records that are exactly the same. So we can do it on table level and we can do it on column level. Yeah, you can say column level as well. Yeah, you can think of it as row level and column level, but yes, that is basically this value counts method. This is really useful in data analysis. Now let's look at the last one, which is basically how we can create how we can export our data frame, our tables. So these are just extra methods. We already saw how to export our data frame to a CSV. It's basically, I think if I'm not wrong, it's CSV p.2 CSV. Yeah, it's actually df.2 CSV. So if we do a df.2 CSV, and if you check the documentation once, we'll see that it takes a path, and the other one is in yeah, let's put the path first. We'll see the index part later on. Let us give it a path. Okay, df.2 CSV, and yeah, the path is slightly tricky, but I think it should be somewhere over here in our file section, probably. I'll call it my file.csv. If I run it, yeah, there it is, my data.csv. I can just download this file and check the result, right? So there is this write file is another way to write to CSV. So we can do something like %%. I don't know if this will work in Colab. The write file my data2.csv, and I can give this data. So I'll do this in here itself instead of Colab, because I'll have to download that again, but I can just show you directly here. So we can do something like, let me get my data frame first. So this is my data frame. Right, let's call it df. I have my data frame. I can save this file. Okay, before that, let me just save it from this one, so that I can just copy paste directly to CSV path my cost data.csv, and if I just press it, I should have it over here. There it is. right? See, it's created at 15:30. It's exactly now. What I will do is I'll just copy this as it is. And I will use this this write file feature. I don't know what it's called, but write file, I will say it's my data2.csv, and then I'll paste the CSV values here. Now if I just run it, you'll see writing my data2.csv. You see here we have a new file my data2. So if I modify something here, I call it I give it some gibberish here, I'll add some gibberish here, some gibberish here, some nonsense here, and I run it again. You will see this will reflect. You see it reflected that nonsense. So that's how you create that's how you write to CSV. This is like a different way of writing to CSV. Obviously this is super convenient, but if we do want to create, we can do it this way. We can also we can create a JSON file as well. So suppose I do we have, like, this is super convenient, right? So we have all this here. I can create a JSON file instead of a CSV. I can do my file 3 JSON, and then I give the opening object curly brackets, and then I'll paste these things directly there. Give me a moment. I will take these directly and I'll just put them here. Each of them, okay, before that, I guess it's better to have commas. I will take these and I'll put it here. So these will act as my objects. Every object has these values. Now if I just run it, I will see that there is a JSON file somewhere here. Where is my data? So there it is, my JSON, my data 3, which is a JSON file. Now if I do a load JSON, df JSON equal to pd dot read JSON, and I give the file name. No colon found when object decoding object value. Interesting. Wait a second. No colon found. Where is it facing an issue? Colon. Colons here. Profession, age. Is it because there is an extra comma? Let me see. No colon found when decoding object value. If JSON 3, my data 3. Let's do it as an array then. Okay. Okay, so I modified the JSON to a JSON array, and then I passed the objects. Obviously, it was a we are passing multiple objects, right? So it's better to have it as a JSON array. Now you see our data got loaded, and that's all there is in this class. Yeah, I hope that was clear, and I'll see you in the next one.